All right, so this is a calculator question. We're doing accumulation functions and definite integrals in applied context, so we're putting this all together. So get your calculator handy. Let's go. So a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon t equals 0 and 8 p.m. t equals 8. The number of entries in the box t hours after noon is modeled by a differential equation E for 0 to 8. Values of E at t in hundreds of entries at various times t are shown in the table above. So watch, this is hundreds of entries, right? So we're going to use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time 6. So time 6 obviously is not on there, but we can find the rate by finding E prime of x. All right, so E prime of 6 equals E of 7 minus E of 5 divided by 7 minus 5. So I get 21 minus 13 divided by 2. I plug that into my calculator, and I get 4 hundredths of entries per hour. The next question says, use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8, the integral from 0 to 8 of E of t. So you can see how here the 4 trapezoids will be 1, 2, 3, and 4. All right, so we can do 1/8, and the formula for trapezoid is 1/2 base 1 plus base 2 times the width. So 1/2, we're going to take 0 plus 4 and then times it by the width from 0 to 2, so that's 2, plus 1/2, we're going to add the 4 plus 13, and then times it by the width of 3, plus 1/2, we're going to take 13 plus 21, times it by the width of 2, and then 1/2, 21 plus 23, and then we're going to times it by the width of 1. And of course, because I used 1/2 every single time, I could have had it with the 1/8. But that's okay. I have a calculator. I can punch it all in, and I get 171 over 16, which is approximately 10.688 hundredths of entries per hour. So it says here, use the correct units, explain the meaning. So that means it is the average number of entries between noon and 8 p.m. was 1068. So now at 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by P of t equals t cubed minus 30t squared plus 298t minus 976 hundredths of entries per hour from 8 to 12. According to the model, how many entries had not been processed by midnight? So if we look at the actual table, at 8 o'clock, we start at 23 entries here. Do you see? 23 entries. So that is our starting spot. So when we do this, we're starting at 23, and then we're minusing the integral from 8 to 12 of P of t dt. So put P of t into your y1, and then we're going to do 23, subtract the integral from 8 to 12 of your y1. So we should get approximately 700 entries. So see if you can get that amount. Okay, so D, according to the model from part C, at what time were the entries being processed most quickly? So most quickly, this is where we're doing a maximum rate. So we're going to use our derivative to find the critical points of P. So find the critical points, because remember when we're doing the extreme value, we're testing the endpoints. So, whoops. We are doing the endpoints, which for that is 0 and 12. And then we're also doing the critical points, which if you find the derivative where it's 0, you should get 9.1835. I would store that in A, and 10.8165 and store that in B. And then from the graph, you should be able to get the value of P of T. You should get at 0, it's 0. Here you get 5.089. Here you get 2.911. And here you get 8. So that means the most quickly is at 12 hours. Make sure you read the question because it's asking at what time. All right. So 12 hours would be 12 a.m. All right, so the second question is now another AP question. There's no snow on Janet's driveway when the snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a model by F of T equals 7T e to the power cos T cubic feet per hour. T is measured in hours since midnight. Janet starts removing snow at 6 a.m. The rate, G of T, in cubic feet per hour at which Janet removes snow from the driveway at time T after midnight is modeled by this piecewise function. So, first off, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? So 6 a.m. is times 6. So we are going from 0 to 6 of F of T. Again, this is a calculator question. So we need to put F of T into Y1. Make sure you're in radians. And if I put this into my calculator, I would get 142.275 cubic feet. All right, so now it's saying find the rate of change of the volume of snow on the driveway at 8 a.m. So at 8 a.m., the rate of change would be F of 8 minus G of 8. So at G of 8, do you see it's 108? So we're going to find F of 8 and subtract G of 8, which I just said at G of 8, that means it's 108. So essentially it's going to be F of 8, subtract 108, and we get minus 59.583 cubic feet per hour. Let H of T represent the total amount of snow in cubic feet that Janet has removed from the driveway at time T hours after midnight. Express H as a piecewise defined function with domain 0 to 9. Okay, so this is where it gets a little bit complicated because at certain times, certain parts of the function, nothing much happens. So for instance, at time 0, we're going to say that H of 0 would be 0 because nothing's happened, right? So then we're going to go between 0 and 6. So T is now going to be between 0 and 6. So that means h of t is going to be h of 0 plus the integral from 0 to t of g of s ds. And you might say, where the heck does the s come from? The s is just kind of like a dummy variable, just so that we can get started here. So do you remember that it says that she doesn't start removing until 6 a.m. So from midnight till 9 a.m., snow accumulates in the driveway, okay? And then at 6 a.m., she starts removing it. So we get 0 plus 0 equals 0. So now from 6 to 7, I'm going to get h of t is going to be the beginning, which is h of 6, plus the integral from 6 to t of g of s ds. So at 6, we're going to have 0 plus from 6 to t, it's going to be 125 ds, which is 125 times t minus 6. Okay, then from 7 to 9, actually I should get rid of this, there we go. I'll just fix that up because it shouldn't, the 7 should just be a less than, there, not equal to. All right, so this is h of t is h of 7, the beginning, plus the integral from 7 to whatever time it is of g of s ds, which would be, okay, at 7, we're definitely into 125 from my piecewise function, plus the integral from 7 to t of 108 ds, which would be 125 plus 108 t minus 7 if I plug that in. So I kind of ran out of room here, so I'm just going to put this here. I'm going to summarize it here. That means h of t, because it's asking for a piecewise function of it. So h of t is equal to 0 when t is between 6 and 0. It's equal to 125 t minus 6 when it's between 6 and 7. And then 125 plus 108 t minus 7 when t is between 9 and 7. So this would be my final answer here. Okay, so then how many cubic feet of snow are on the driveway at 9 a.m.? So again, at 9 a.m. it was accumulating from time 0 to 9 of f of t dt. And then we are going to subtract how much that Janet has removed, and the removal rate would be h of 9. So then that is, I'm just going to move this up. 0 to 9 of f of t dt, and I'm going to replace h of 9. I'm going to look over here. H of 9 should be the 125 plus 108 t minus 7. So this is going to be subtract, maybe big brackets, 125 plus 108. My time is 9, so it's going to be 9 minus 7. So if I put this all into my calculator, I get 26.335 feet cubed. And that's how much cubic feet will be on the driveway at 9 a.m. So a lot of these, you just get better and better with practice. just keep on plugging away.